Hello, this is Carmine Remy. I'm your host for today's webinar, and we are going to talk about getting started easily with CICD, continuous integration and continuous deployment. Those are two of the hallmarks of DevOps. DevOps has been around for quite some time, and so we'll go into these two core pillars. And in the process, and as we do some demos as well, we'll look at some cloud-native technologies and technologies that are used as part of that. Ubuntu, the operating system. Multipass is a relatively new tool that can be used to get you an Ubuntu server, an Ubuntu prompt, no matter what kind of desktop you're on, whether it's Windows or Macs or some Linux system, as well as MigraK's, one of the best, fattest, and fastest, I should say, and tightest Kubernetes. It's a single node Kubernetes deployment that, as you'll soon see, will help you be a lot more productive and efficient and effective in your CI/CD endeavors. So without further ado, let's go ahead and look at the agenda. First, we'll go over an introduction to Canonical. Canonical is a sponsor of this webinar, and it's the company that I work for. It's a great company, and we are hiring, so if you're looking, please feel free to look at our website and look at some of the career opportunities for you. We'll get into a brief introduction in CI/CD. Then we'll look at cloud-native CI/CD, demo, and questions and answers. All right, so Canonical is the company behind Ubuntu. Started over 14, 15 years ago. Ubuntu really has become extremely popular just around the world, I guess you could say, in this galaxy as we start to travel into space and things like that. So as you can see, this slide is pretty dense, but the message here is that Ubuntu is everywhere, and more people use Ubuntu than you might even realize. From down there, the number of Docker images, and this is a cloud-native CI/CD, so when we talk about containers, Ubuntu is the most popular operating system that is used as part of people's containers, as well as even on virtual machines. So whether you're up in the cloud, whether you're on your laptop using Vagrant and VirtualBox and things like that, you'll find that Ubuntu for developers is the #1 go-to operating system for people to use. And I think a big part of that is we do believe in developer productivity and efficiency, and really eliminating the friction that developers might otherwise experience when using some other operating systems. As you can see at the top here, a lot of instances of Ubuntu launched since 2015. And then over in that right-hand column there, when we start getting into IoT and Ubuntu, you'll find that Ubuntu and IoT, Internet of Things, is a natural fit. Again, back to that efficiency, that small footprint, and focusing on handling a lot of the different use cases that matter for developers to build and deploy applications, all the way down even into everyday life. We look at some of the cars, some of the vehicles and autonomous driving that are using Ubuntu at the heart of that, as well as some other devices. So Ubuntu, if you haven't played around with it, I definitely encourage you to play around with it. It is the operating system that is, generally speaking, the most current, the most up-to-date, the latest features that you'll find in your open source projects that are using just have a natural home and velocity on Ubuntu. All right, not only do we make an operating system, but we also have one of the best packaging for Kubernetes. Everything from your day one sort of initial setup into a production environment to day 2 lifecycle management of Kubernetes. You'll find that Canonical and Kubernetes and our packaging of Kubernetes, both in that enterprise setup, as well as MicroK, which is that single node setup that I talked about at the very beginning of this webinar. We'll get into a lot more details soon. But here you'll see some of the value proposition of why you might want to try out Charmed Kubernetes. If you go to ubuntu.com/Kubernetes, you'll get more information in terms of the different packaging, including MicroK, as well as Charmed Kubernetes. It is pure upstream. It operates just about everywhere. So if you're in a multi-cloud environment and deploying to several of these places, whether it's AWS or Azure or Google, OpenStack, VMware, bare metal. You can use the exact same operational primitives to deploy and automate your deployment of Kubernetes, whether it's a small environment, a small number of worker nodes, to a massive number of worker nodes. You'll find that our Charmed Kubernetes does a great job of keeping you on Rails and keeping you informed and helping you essentially manage your cluster and many clusters at that. The bare metal operations is with MAS as well. Metal as a service is fantastic. It's a great experience. It's sort of a match made in heaven. And as you can see, 100% compatible with Google's Kubernetes, secure, upgradable, cost-effective. And the upgradable part is really critical. We have, I think, one of the best upgradable stories when it comes to Kubernetes. The recent security issue that was there, we had it fixed within 24 hours, and people that use our Charm Kubernetes would have had their deployments upgraded within that sort of 24-hour period, which is very, very important. We take security very seriously. And a lot of the underpinning technologies that we use, which I won't get into here, go a long way towards keeping you secure and keeping your deployment secure. And cost effective. We believe that the economics of cloud and the economics of development matter. The lower the cost, the more you will be free to deploy and use Kubernetes and some of our other technologies, so that, again, the cost isn't an impediment and the cost isn't a friction in terms of you using some of this great and fantastic technology that's coming around. All right, with that corporate sponsorship and that corporate announcements in terms of who we are and what we have and why you should pay attention, let's get into CICD, shall we? This is a very high-level overview of continuous integration, continuous deployment. So people use CICD a lot. There are, I remember in the beginning of this, sometimes CICD, as you can see with number 3 on this list, the CD part sometimes stands for continuous delivery, which really means as you're building your software assets, whether it's a container, whether it's a Java jar, whatever it is that you are building, whatever software you produce, and however it gets compiled and tested and put into some sort of binary artifact. The continuous delivery just meant that it's going somewhere and it's getting stored somewhere so that everybody can get access to it. It doesn't necessarily mean that you are putting it into some staging environment or production environment. And that's really, so that's why I put a small d there, as you can see right here in the middle. The continuous deployment part is where you are continuously deploying to some one or more environments. It could be a development environment, a team environment, then to staging. Maybe you have an alpha or beta environment or pre-prod, and then production. And as part of that, a key part of that is the fact that you've automated all of the steps required to not only deploy, but if you already have an application that's deployed, how you go about updating and upgrading that application. As well as just so that part is automated, as well as you have the right processes and gates in place to make sure that as you promote artifacts from one environment to the next, you have kill switches and other kind of tests and canaries and a whole suite of things that go into making sure that if you wanted to, you can push many times a day. That works well for some people. It works well for some applications like a web UI or something along those lines. Some organizations have gone all the way to where they're doing tens or hundreds of deployments a day. And for some teams, they've pulled back and said, that's too much change. We need a slower cadence, whereas they could deploy that quickly. Because of where they sit in the application stack. Maybe it's more of a platform piece. They want to have, I don't want to say better testing and more automated testing, but in the scenarios where something could go wrong, then doing it at a time where it's maybe more safe to do that. And that could be once a day at a particular time of the day, or it could be once a week, again, at a particular time of the week. And lastly, your runtime environment. So as you can see here, from the developer all the way to the left, or I should say the engineer, it could be any kind of engineer, not just a developer. A lot of times we think of software engineers, hacking away at their laptop, producing and making some changes, whether it's to software or even to operations. And that's where you get into GitOps, which isn't a subject of this conversation, but it is one of those things that is top of mind and on the radar for a lot of people. If it isn't on your radar yet, then certainly do a Google search on GitOps and see what that's all about. Excuse me there. So that's you'll check your software into some sort of repository. That's the code repo here, that third circle from the left. That will get into your continuous integration, which will consume that change, do whatever tests you've specified, do some functional unit tests, functional tests, acceptance tests, and that if you're familiar with TDD, test-driven development, or behavior-driven development, or acceptance test-driven development, there's a lot of driven development, which I won't go into detail here. That's probably the topic of another webinar. But all of those driven development scenarios sort of presume that you have a really good and really tight development and testing cycle, so that you can write a test, write your code, validate that the code fixes the test. That test, if you're writing it up front, does sort of go into whether or not, it shouldn't pass because you haven't written the code yet. And I don't want to digress too much into all of the different, developer-driven and test-driven development type scenarios. But it's an exciting area that I can spend a lot of time into. But that's continuous integration. And there's a lot of technologies there that help you take any changes to your artifacts, do the tests, and roll it out to other different environments. And that's really where you get into continuous delivery of those artifacts. So once the continuous integration, the build machine either produces it and or runs some tests, it'll put it into some sort of repository. Here, when we think of cloud native, we'll think of containers and building containers, doing some tests on those containers and putting them somewhere where they can then be further operated on in terms of adding tags to it and move from one environment to the next. Continuous deployment and then runtime environments. And again, that continuous deployment piece is really, once you've got that continuous delivery and you've got those artifacts somewhere, the continuous deployment piece is taking those artifacts from one environment to the next, and with increasing confidence, getting it all the way into a production scenario. And that's what the different runtime environments look like. Okay, so that's our basic setup, our basic introduction. Now let's get into sort of a cloud native view. So this is, there's a lot more logos that I can put onto this slide. But again, with those same circles down at the bottom, here are some technologies that you might look at as you do part of your development processes. Everything from the type of operating system you might have on your laptop. Windows is still by far the most popular desktop laptop environment. Mac and Apple is a distant second, and then Ubuntu sort of third in that list. And as I mentioned at the very beginning, with multipass will help you and allow you to very easily, whether you're on a Windows or a Mac, get you to a Ubuntu prompt where you can then take advantage of the CICD technology that we'll talk about, and all these different logos here. All of them deploy easily and naturally in an Ubuntu environment. But you need to get to that Ubuntu prompt, right? And that's where multipass comes into the picture. And again, we'll talk more about that. On the code repository side, Git is everywhere, GitHub, Bitbucket, you name it, in terms of the software as a service consumption of Git repositories. And then, of course, you can install it locally. Here, we'll look at GitLab in more detail. As well as there's a lot of stuff going on in continuous integration. I put in Jenkins, which has been a stalwart for quite some time. There's other things here like Typical CI Worker and a whole bunch of other logos and new things that are coming down. People taking a fresh look at, how can we do continuous integration in a way that is modern. Not to say that any of these aren't modern. Certainly Jenkins X is trying to take a modern look and opinionated look at Jenkins. But there's a lot of exciting things going on in this space. And so if you like to be at the cutting edge of what's going on in continuous integration, and you like to look at what people are trying to do to remove any friction, remove any impediments, and make this a productive area, then certainly it makes sense to spend some time here. Into the continuous delivery, a big part of that is that you have a place to store these assets. And then up at the top left there, any sort of OCI, Open Container Initiative registry sort of compliant place that you can put containers. But a lot of times you might not just put containers, you might put other things, like I mentioned earlier, your Java packages and stuff like that, things that get built and things that get used by other things as part of your build process. And so that's where you might get something like Nexus, which is right here on the bottom right. You might use that as part of your tool chain. And it's been around. There's other technologies that have been around for quite some time. JFrog's Artifactory, things like that, as well as something that can be naturally to be used. And over time, some of these technologies that have been around for 10 or 20 years have morphed into, hey, we already store your artifacts. Containers are an artifact. Let's go ahead and add that as one of the artifacts that we can track and make it available to developers and use the common primitives that they've used in the past to, again, track and manage software artifacts as part of your CI/CD pipeline. In the CD area, which is probably a little bit, I would just say newer than continuous integration and to some degree continuous delivery. We've had build servers forever, even back in the 80s and 70s, et cetera. The continuous deployment is, relatively new in that landscape. Spinnaker is getting used in Anger in a lot of different places, as well as some newer things like Argo. Juju and Snap are technologies that Canonical has created that actually make life a lot easier and simpler, particularly whether it's from IoT over there sort of upgrades and updates to other scenarios where that automatic upgrading of software out there, very similar to how on your phone or on your tablet, you might have applications that get automatically updated. Juju and Snap are another set of technologies that help you do that as part of continuous deployment. And then lastly, lots of different places you can go and do your runtime environments, from public clouds to local scenarios. All of these places are areas where you might set up your own environments. And locally, you might either use something like LXD or OpenStack or MAZ or microcase, as we'll talk about soon, and as part of that multipath. So again, that's one runtime environment. Hey, how do I sort of run the stuff locally? To then, hey, how do I run this in a cluster? And this talk, and since it's cloud native, we'll focus a lot more on Kubernetes and the different places that you can set up Kubernetes. Okay, so that's kind of some examples, some resources that you might use, and as I mentioned, we can put a lot more logos on here. There's a lot of technologies that you can leverage. But here, as part of this talk, we're going to focus on a few pieces. And these pieces are, as you see here, we'll focus on Ubuntu, GitLab, we'll focus on Jenkins, we'll focus on Nexus, Spinnaker, and Kubernetes. And we'll show you how you can go through this entire process leveraging those technologies, and how through this example in this talk, we can look into how to do this easily and how to do this with some support. So there you have it. Anything else here worth mentioning? I guess as part of this, and I think it's worthwhile talking about, and it's part of this talk, is I do want to mention that some of these environments and some of these tools, the one way to think about them is, hey, I want to set one of these things up and I want it to be a long living process. One of the things I enjoy doing is talking about sort of ephemeral environments and ephemeral stacks. As you can see through this process, you will see in the demo, these technologies can set up fairly quickly, and they can set up in confined areas like a virtual machine that you might set up with multipass. And once you actually make these things really easy to consume and easy to set up, it means that they don't need to necessarily be as permanent. And particularly when you have a great story around storage. And if I can turn the lights off and then turn them back on, and you still have everything that's important to you, you still have all of your build information, your artifact information, and it's just a matter of seconds or minutes for these things to kind of spin up and spin down, then that to me is sort of exciting, because it means that you can do this easily on your laptop. You can do it up in the public cloud and save yourself some money if you're not on continuously building, if you're not making a lot of different changes throughout the day that you are where you need this environment and the complete set of tools in this environment. Then again, that's kind of interesting, and it's interesting to me. So that'll be reflected, and you'll see some of that as I talk about through the demo. All right, and so I kind of alluded to some of this. One of the things that's also interesting to me is I do travel a lot, and with this tool chain, once you set it up, and you set it up in a virtual machine that you can easily spin up, what's exciting about that is if your own applications that you're developing, if you rely on other containers, by setting this up, you will be able to effectively and essentially do your builds, do your development while you're on the plane or on the beach somewhere in the world without access to the internet. And not only in those scenarios is it important, because obviously you don't have access to the internet, and so being able to cache these things locally is imperative if you want to be productive. But also, even if you do have access to the internet, or you're somewhere in the world where your access to the internet is great. I spend most of my time down here in Australia, and there are, there's links to the US, and a lot of this stuff, a lot of containers, a lot of artifacts, a lot of other things are in the US. As you can imagine, in various parts of the world, the number of connections and points of presence or POPs that you might have with links to the US, those can represent choke points. So if you can bring this into your own environment, bring it into your own laptop, and do builds from there that rely on that, then you can imagine builds going from minutes and tens of minutes down to seconds, because it's all there and it's all there locally. So that's some of the benefits I want to mention is, fast builds, fast deploys, and a big part of any test-driven development sort of cycle there in agile development is having that really fast build, deploy, test. And there's a lot of scientific studies that look at the tighter you make that, the more you'll do that, the more you'll test, and the more you'll make those small little micro loops of test dev, which improves the quality of your code, the robustness of your tests, the better you'll have in terms of regressions, etc. All right, so those are some opportunities that I think are worth talking about here, and I didn't want the opportunity to go away. Now, with that, and then covering CICD at a high level, and then some technologies and some of the things that we're going to focus on, now let's get into a deployment diagram.